Thanks for everyone for joining. My name is Qinglan. I'm one of the software engineer at Amazon Web Services. And today I would like to introduce you with DJL library integration with ONNXRuntime. Basically, we have a few kind of the use cases that are aligning inside of Amazon and also outside of Amazon that have been successful, proving that the ONNXRuntime actually have a very good performance. So let's go with the next slide. So firstly, let me introduce what is a DJL library. It's one of the machine learning libraries that are built on top of the Java, but more on the application layer. It's actually doing an abstraction of all of the deep learning libraries, just like Keras. And it currently has a set of the NumPy-like operator that we have been implementing inside of Java. And inside of the NumPy, like the operator, we're actually leveraging the deep learning engines that's like Apache MXNet, TensorFlow, and PyTorch by using their C and C++ API to offering the operator support. And also on the engine side, DJL library, since it's an abstraction layer, is offer multiple backends. It can run Apache MXNet, TensorFlow, PyTorch, ONNX, Paddle, and a lot more. And even with even including the machine learning library, just like the XGBoost. We also have a set of the model zoo support with more than 70 pre-trained model that can be run directly within Java, like the popular Hugging Face models, or like the models from the Torch Hub, from the basic image classification to object detection, sentiment analysis, and also action recognition. And the best advantage for DJL library itself is basically it's service ready. We have been doing a very thorough test run with DJL library to ensure it has the best performance and also have a control over the memory. And we have been consistently running, and currently the service has been running with DJL has been successfully for more than half a year with no errors happening. Next slide. Okay. So here I would like to share with you guys about like a couple of the successful customer by leveraging ONNX and also ONNXRuntime by leveraging and also like with DJL use along the way. The first use case is basically came from Amazon advertising. We have been helping with the teams that are trying to launch a model that with a very heavy infrastructure. And basically previously the latency in advertising that does not meet the actual inference goal. Basically, it's like 22 milliseconds. But after using ONNXRuntime, switching from that, it can actually reduce the inference time from 22 milliseconds to less than 15 milliseconds. That's basically the number on the P90. And also, like after switching to ONNXRuntime, we can also providing the thread-safe multi-threading inference by leveraging the multi-core CPUs. On the other side, after doing the conversion between the MXNet to ONNX, we do the correction test to ensure that the output after the conversion is still being the same. And we observe it's less than e⁻⁷ difference on the floating numbers. Similarly, we have the stories that successfully converting from PyTorch to ONNX, which is in the hyperfactor. Since the CTO is here, so I will probably just let him to introduce more. On the other side, we also have the TensorFlow to ONNX conversion successful by using DJL libraries. We have Amazon search team here. That is actually they have old TensorFlow models, and they really want like a performance boost on their inference side. So after converting to ONNX, the inference time are reduced from 12 milliseconds to less than 4 milliseconds. And since DJL library is supporting multiple framework, they also converting a couple of their scalar models to ONNX. It also have a very good performance. And finally, it's something that is that wasn't from our expectation. It's actually from the Chinese market, because there's a huge amount of people are actually leveraging Paddle, and Paddle is also one of the deep engine that DJL library actually support. There are a few of the companies reach out to us to see if there are any performance gain they can get from Paddle. Because of their original engine doesn't support the thread-safe multi-threading, so they have no way to accelerate the inference by running on the CPU. After converting to ONNX that have the supporting from us, they successfully, like one of the top bank from China, they successfully making their OCR models runtime from 1 second to less than 400 milliseconds on a single image. However, most of the people, especially for people who is using ONNX Runtime, they always facing a very big challenge is how, because there's no built-in operators, they cannot easily doing the pre-processing and post-processing inside of Java, especially on the n-dimensional array operation. So DJL library offers a solution. So we introduced a new concept called the hybrid engine, and essentially is, in fact, it's just trying to load the both two engines together at the same time, and also it provides a smooth transition for customers, especially when they're trying to switch the engine between, like to run for the inference. So basically, all you need to do is just have a master inference engine. In here, we just use the ONNX Runtime, and one process engine. In here, we also use the PyTorch in here. And since we're supporting all the operators by using PyTorch, TensorFlow, and MXZ, the user can choose one of the engine to be served as the processing engine. And to reduce the data copying time, instead of like trying to copy the data from Java heap into the C++ layer, we introduce the way by using the direct buffer to send the pointers from the PyTorch directly to ONNX Runtime. This avoids the data copying and also providing a very huge performance boost on the inference side. If you're trying to comparing, you run the end-to-end inference with PyTorch and this hybrid mode. And finally, the way for us to control the memory management, we creating something called ND Manager. It's a tree-like architecture that has been implemented in DJL library to replace the garbage collection system inside of the Java to provide the more cost-effective memory collection stuff. So basically, having this ND Manager built in mind, we can actually making all the inference very clean without any kind of memory leaks. Okay, next slide. So here you can actually see how the simple the experience is going to be. So DJL library offers us a criteria class where the user can define how their model is going to be loaded. They can offering a model URL. Basically, it can be a file URL, it can be a general HTTP URL, it can even be an S3 link, and also HDFS link. And also you may need a translator, and the translator is an abstraction class that DJL library offers that can be doing for the pre-processing and post-processing. So previously, when the user are actually leveraging the PyTorch, all they do is simply doing the PyTorch in the option engine side, and they load the PyTorch model to run for the inference. And if they want to use the performance boost by running ONNX engine, all they need to do is just convert their model to ONNX, and then without changing a single line of code, just change that engine to ONNX Runtime, they can have the performance gain. It's very simple for customers to do the transition, and that's why DJL library actually having a lot of customers are leveraging ONNX Runtime for their inference optimization. And final slide. Yeah. So what's next with ONNX Runtime and DJL library? So in the next phase, we're going to support for the ARM server because we see there's a trending demands for people who are trying to leverage ARM-based device for the cost advantage and also the performance boost. And also we're trying to hit into the edge devices, especially like the Android support. We're trying to run the ONNX Runtime there as well, and hopefully we will bring the hybrid engine solution to there, since we are already supporting the PyTorch inference on the Android device. Yeah, that's it. Thank you.